familiarize you with different technologies and different basically different terminologies, different texts, different stacks that are used in blockchain and Web3. So what we are trying to do is we are trying to have these mini sessions wherein we just try to introduce you to. It's obviously not possible to give you an entire descriptive course about those topics in 15-20 minutes, but it is just to make people aware of what those topics are, how they work, and maybe you have heard about those terms and stuff, but it is just making sense of those. And if you want to learn more about that, or basically try your hands on into that, or get onto real life projects, like Kriti said, there is a training session that also is organized by Skillwise for a 6-week period, which you can definitely involve for as well. So today's session mostly is related to cryptography, and so that in blockchain and cryptocurrency, they pretty much go hand in hand in terms of whenever we talk about blockchain, cryptocurrencies pretty much are something which I mentioned. And the word crypto in that, it's basically comes from the cryptography and how data and everything is secured using cryptographic techniques. So the this session and the following two sessions is something wherein we will be trying to basically let you know about what cryptography is, different methodologies, how and why that is required. So that is the plan that we have. So I'll just quickly share my screen, and Riti, if you could just allow the
Yeah,
screen
sure.
sharing for me, please. Thanks, sir. So, please do let me know once the screen is visible, please.
Yes, it is.
Thanks, sir. So this is the session, one of the three sessions that we have around this topic, which is cryptography. So the idea behind this first session or the mini session is to make you understand what cryptography is and why do we need it. Uh, what is the history behind cryptography, the different terms that are involved in it, like encryption, decryption, and stuff, and where does it fit into the scenario of a blockchain, and how does blockchain leverage cryptography? So saying that, I'll just start with a very uh, base definition, sort of a, if you could say this is a definition or an understanding of what cryptography is. So cryptography is nothing but it's an art of keeping information secure. Uh, so by transforming it into a form that is something which the unintended recipients don't understand. So in terms of whenever we are working in a network, or whenever we are in a situation where we want to transmit or transfer information between parties, sending and receiving information is quite easy in a network or anywhere. So whenever you do communicate, the transfer of information is not the problem, but securely transferring the information to the intended recipient is a problem. So where does this cryptography comes from? So it's not a new technology, it's not a new term, or it's not a new concept that we are using just in computer sciences or in blockchain, but this is something which has been long used in the past as well, starting from the Romans to the Germans to till the time in history. We can look at different instances where cryptography in some form has been used. So saying that, in cryptography, any human readable message or any message that we want or intend to transmit or send to a recipient, which is in a readable format, it is referred to as a plain text information. So whatever we can read or we can make sense of, that's called as plain text information. Cryptography, it changes that plain text information by means of an algorithm or a series of any operations, mathematical or other operation, into a different form, which is uh, unreadable, or it's sort of a gibberish for anyone who doesn't know how to decrypt it back. So the process of converting that plain text information using the algorithm or mathematical operations into a different format, an unreadable format, is called encryption. And that encrypted data that you have, that is also called as a ciphertext. And this is a process which is twofold. So if you are encrypting a data, meaning if you have a plain text information which is readable, uh, if you encrypt that using a cryptographic algorithm and you convert it into a ciphertext which is non-readable, and then you send it to a receiver, the receiver also needs to read that. He cannot make sense of the ciphertext, so he needs a reverse operation which basically does the exact opposite and gets you back the information into a readable format. And that process in itself is called as decryption. So this entire process is called, or this entire technique is called cryptography, and the conversion of plain text to ciphertext is called encryption, and its reverse, which is the cipher to the plain text, is called as a decryption. It's as simple as that. So now, saying that, when I mentioned that this is not a new technology or a new concept, so if we look back into history, one of the things that, or one of the uh, early recorded history of cryptography comes from something which was used by Julius Caesar. And what he used was, in his time, the Romans, what they did is about 2000 years back, is they used something called as an sort of an alphabet shift ciphers. So obviously they did not use the alphabets that we use right now, but what they used was they used something called as alphabet shift ciphers. Like for example, in this, the example on the left that you see, this is something of an alphabet shift cipher with a like a shifting of three characters to the right. So like if I want to send A, I would send D. Like if the algorithm says that any character that you send, any text information that you send, the plain text information would be converted to a value wherein every alphabet would be replaced by the third alphabet next to it. So if we are sending the plain text information contains A, the ciphertext would contain D. So for B, it would be E. For C, it would be F. So that is where any information that you send, that would be basically every character would be shifted 3 times to the right in this. But that 3, the value 3, the in this shifting of characters to the right for making a plain text to a ciphertext, that can be said to be an algorithm, encryption algorithm, wherein the algorithm is what? It's a method, it's a process, it's how we want to do stuff. So for us, that algorithm could be anything. There are different standard algorithms for encryption, decryption that are available, but but an encryption algorithm can be as simple as this, wherein you just replace a particular character with the next characters, n number of characters after that. So that is a very simple operation. So our algorithm is the shift operation. And in this, if it was always 3 characters, then maybe after a few transmissions, if someone is monitoring our communication, they would make out what this is, and they would always be able to figure it out. And they would just shift it left to 3 characters, and they would understand our encryption algorithm and decode it, and it won't serve the purpose. So the value, like how many characters need to be shifted, that is something which can be dynamic. For a certain transmission, I would shift 3 characters. Maybe for some, I would shift 5 characters. For some, it might be 2 characters. So that variable value that we are seeing, that is something which provides a uniqueness with every encryption operation. And that can be, in a sense, said to be as a key. So we know what needs to be done, which is the algorithm, and we know how many characters need to be shifted, and that would be the key. So I just need to tell we both know that it's a shift operation, but I just need to tell the receiver that shift 3 characters or 5 characters or 2 characters for this transmission, and they basically do that, and it's a decryption that also does the same. So this is a simple sort of encryption or cryptography that 2000 years back Romans used. A similar but more complex sort of encryption or encoded communication was something which Germans used during the Second World War, wherein they used a machine like what we are seeing on the screen, wherein they called this as an Enigma machine. And it was that time that they did all their communications by encrypting their messages through the Enigma machine and decrypting it on the other side using this. And they had their own mechanisms for this. And it was quite long that after that the Allied forces pretty much came to know about it, and they started working on it, and then they figured it out. But these are some of the very old instances which I just wanted to share, just to put a context that cryptography is not something which is very new, and it is not something which is just used in computer science. It can be used, and it has been used in different aspects of our life from quite far back. Now, why cryptography is used? So first and the most important reason is to keep the content of a data that you want to transmit confidential. So that is the paramount thing that you want. You do not want any communication to be divulged to someone who is not intended to receive that. So that is the first part, wherein during a conversation or during a transmission of an information on a public network, which is non-secured, you still keep your data confidential. The third one is authenticating the identity of a messages sender and receiver. So what we will see in future sessions is that different types of encryption and cryptography mechanisms are used, wherein you can, like in blockchain, like the blockchain private public key. That is basically a key, a public key, which is used to encrypt the information, and at the receiver side, the private key is used to decode that. And we also know from basically the signing can also be done wherein it authenticates a validity of a user. Then it ensures the integrity of the data, showing that it hasn't been altered. So encryption by signing the keys, by signing the data using an encryption key. What you can also do is whenever the data is received by someone, you can basically verify whether that information that was sent by the user is exactly the same that you have received and it hasn't been tampered with. So that is where it is also used. Demonstrating that the supposed sender really sent this message, or what is known as non-repudiation, meaning that you ensure that the message, the sender who claims a message that comes to you and the sender who claims to be someone is exactly the same person who he claims to be. If that can be basically verified, then that is also a very important task of this particular cryptography technology, which is known as non-repudiation. So these are something which are generic and general concepts of cryptography and why cryptography is used across the board. But there is a specific reason or why cryptography is used in blockchains. So in decentralized systems, there is one problem. So network systems could be centralized or decentralized. So as we know, blockchains are a decentralized network. But in a decentralized networks, these actually only the decentralized networks are susceptible to something which is known as a Byzantine's general problem, wherein because they lack a dependable source of information and they do not have any way of confirming whether the information they get is from a authenticated user or from some other network user. In central systems, the central authority is basically trusted to disseminate or any information which should be accurate as per the central node, while preventing any sort of erroneous or fraudulent information across the network. So we trust the central server or the central node to only disseminate information which is non-fraudulent and non-erroneous. But in a distributed network or decentralized network, that is a problem, where because there is no centralized authority which basically says that this is correct or this is incorrect. So that's where this this is a this Byzantine's general problem that that I mentioned in here. It's sort of a game theory. So what it says is that in as per the Byzantine general problem game theory, what it mentions is that uh, the soldiers or different armies basically want to attack this Byzantine Empire, but to succeed, they all must attack at the same time. If the attack is not coordinated and done at the same time, they lose. But if they all attack at the same time, they can win. Now, for this, all the generals basically have to coordinate among themselves, wherein they have to coordinate the attack and everyone has to be on board to basically attack at the same time. Now, there could be various different problems in this, and those problems could be that the information that is, say, this blue general wants to attack and passes the information to the red, then to the green, and then to the white. But in between, the information gets lost, or the information is modified by either the defenders or someone else, and that gets the coordination basically doesn't happen and the attack fails. So this is where the cryptography and the cryptographic hash algorithms basically are inbuilt into the blockchain, which basically uh, allow blockchains to have a solution to the Byzantine chain problem. How they do that? Any transactions that we do, say for example, it's if it's done on a centralized system, it is the central authority like the banks. They basically tell whether the transaction is genuine or it's a non-genuine transaction, and whatever they say, that is final. So that is a central authority system, but in a decentralized system that is not the case. So in here what happens is, for a transaction to become part of the blockchain, which is a collection of all the valid transactions, whenever a transaction is made, it by default doesn't go into the blockchain. And that is where a network of validators or authenticators come into the picture, who are called as miners. And they basically solve the mining equations or mining calculations. And then they all basically tell whether a particular transaction is valid or invalid. And there, if the majority, which is more than 51 or more percent more than miners basically say, if the transaction is a valid transaction, only then it basically goes to your blockchain. And that's how blockchain has managed to solve this problem of Byzantine general problem and maintain the sanity of the network and maintain the accuracy and security of the blockchain networks, still keeping it as a decentralized node. So for the next sessions, we will basically be looking at different encryption, decryption mechanisms like symmetric, asymmetric, and how in blockchain, which is the type of encryption or decryption methodology used, which is ECDSA. So those are some things which we will be trying to cover in our next sessions. So for today, it's all, guys. Thanks a lot. If there are any questions, I'll be more than happy to share those. Thank you.
Thank you, Abhijit. Abhijit, do you want to talk about the signed transaction and unsigned, and how does it work?
Yeah, so in a signed transaction, what happens is that when you have when you what we saw in the past few weeks is that how we created our own accounts in blockchain. So those accounts were basically addresses, and we saw that we had a public address and a private key. So that public key and the private key is a key pair, which is your identity on the blockchain. And as I mentioned, the public key is something which you can circulate among everyone, and that is where everyone sends you transactions, and to claim those transactions you have the private key. So when you make a transaction, that key which you have given to people, that is used to sign the transactions, and those signed transactions are basically, so whenever a transaction happens, there are basically a number of steps that happen in the background. First, the transaction is created as an object of information, then that is used to basically sign the transaction by the sender's private key. So when the sender sends a transaction to anyone, he uses his own private key to sign the transaction that this is the transaction that I have made. And that goes into the blockchain by broadcasting it. When that comes to the blockchain verifies that and sees whether it came from a valid source of information, valid source or a valid address, and whether that address who has sent and signed the transaction has enough value or enough balance to make the transaction or not, or whether he's trying to do a double spending, which means that I try to spend an amount which is still not with us. I have already spent something and I'm trying to again spend that. So I cannot spend 100 rupee note twice. So that is where the miners check that. And once that validation is done, the mining is complete, the transaction is validated, automatically the recipient starts seeing the balance in their account because it contains the receiver as the public address of the receiver. And to claim that, the receiver uses his address or his wallet where his private key is, and he basically claims that transaction which has come to him. So that is how this entire thing happens.
Oh, thank you. Thanks for that, Abhijit. I mean, if you have some time and you want to show it in the context of the Flowcard wallet that we have done and how exactly transactions are signed, because I think for people, when they go and see on the blockchain transaction, so between a wallet and a transaction, what is a correlation? That would be a really nice update.
Sure. So I'll just try to share my screen. I'll just would go through a small piece of code base for you, which is a sort of a which I'll just explain to you how that entire thing happens. It's a small code base that we have written in C#, and that basically does all the magic in the backend. So just give me one second. Okay.
So meanwhile, people, if you have any questions, you can ask or put them into a text box. But in general, the idea is that cryptography plays a very important part. I mean, it's built on the premise of all the engineering that has been done before. So one of the myth buster factors that there's nothing new per se on the cryptography when it comes to blockchain. It is more of an implementation that has been done. So what we are seeing here is an actual good use case of a cryptography in action. And thanks to blockchain, it works out pretty okay.
All right, so I've just shared my screen. Do let me know if it's visible.
Yeah, it's visible, Abhijit.
Okay, thanks a lot. So what I'll just like to show over here is that it's a small library function that we have, which basically does all the backend transactions that whenever we do any transaction on Flowcard, this is the function that basically does the transaction. So it requires the information that it requires are the sender address, which is the public key of who is sending the address, the private key of the sender who is sending the transaction, the receiver, the public address of the receiver, because that is the one that we would be having, and the receiver basically would claim it on their end. But to send this, we need the sender's public address, sender's public private address, private key, receiver's public address, what information we want to send, which is the flow data, which we mentioned in the previous week, that flow data is the 1040 characters of information that we send, and the amount that is being transacted. So any blockchain transaction cannot have a non-value transaction, non-value transfer. It has to be a value transfer. It could be a very small value or a large value, but it has to be a amount that needs to be transacted between the receiver and the sender. So the steps that we take during a transaction broadcast, what happens is that first we convert the amount that we get, that we want to transact, and we convert it into a decimal format, which is the one which blockchain understands. We can have the amount in a decimal or in string, but we need to convert it in decimal first. Then what we do is there is a transaction fee that we also need to specify. So a transaction fee could be dynamic if you want to calculate how much transaction fee you want to send. But for flow data, for flow card, what we have done is we have set a specific transaction fee, which is 0.0001 flow for every transaction that we do. That is a transaction fee that we pay for to the miners for every transaction that we make on flow card. Now the second step would be first to check if there is if there is balance in the sender's wallet or not. So the address that is used to send the transaction, whether that has enough balance or not. So for that, what we have is we have this small function that I will just dive into, which basically checks your address balance. And this calls up one of our APIs, which gives us the balance when we pass in the address. And the way it calculates the balance is that there is a something which is called as an unspent transaction. So unspent transactions are all the transactions that you have received in the blockchain from different parties for whatever denominations, but which are still unspent and are still with your address. So what we do is we basically collect all those unspent transactions from the blockchain which we have received. And there is an RPC called which gives us those informations of all the unspent transactions. So as soon as we get that, it's an array of transactions. And what we do is we get the amount value from all those unspent transactions and we total those amounts. And the amount that we get as a totaled value, that is our balance. If that balance is greater than the amount that we are trying to spend, then it means that we can do the transaction and we are on the green. But if the amount that we have as a balance in our address, if that is less or equal to, actually less than the amount plus the fee that we want to spend, it means that we do not have sufficient balance and we cannot proceed with the transaction. So what we are doing here is we basically check the balance first and then see whether the balance is less than the amount plus fee. And if that is the case, we return the client a message that flow address has insufficient balance and the transaction stops there and nothing happens. But if that is not the case, we move ahead and we again list all the unspent transactions that I just talked about and we start collecting them. So now to create the transaction that we are now trying to send, we if let's say I have about 100 flow tokens in my account, but I just want to send one, and just hypothetically if I consider that my unspent transactions are all in denomination of one flow address, so when I collect all those transactions which are available with me, I do not want to send the 100 tokens to you and get back 99. What I would want is I would want to send the least possible denomination to you, which is required to make the transaction happen. So that's where what I'm doing over here is we are listing all the transactions that we have available as unspent. We are iterating those. And as soon as we get an amount which is just above the amount plus the fee, we stop collecting those unspent transactions, which means that if that requires 2 transactions, unspent transactions, or 4, whatever number of transactions we require from our unspent pool, we just collect those. And as soon as we get enough number of denominations as unspent transaction, we basically keep them into an array which is called as inputs. So this is the first object that is required for a transaction, which is called as inputs. So inputs contains all the unspent transactions that you have, a minimum number of unspent transactions that you have, which is required for the transactions. Once that is got, now what we do is we create our object with the inputs with the number of transactions that we got. Output is basically the receiver's address. So output contains to whom you want to send a transaction to. So it has to be at least one address, which is the recipient's address. And if the denomination that you are sending is above the amount plus the fee, it means there would be a change that will be generated. So if I want to spend 1.5 flow, but I send 2 flows, it means that I will get back 0.5 flow, which will be considered as a change. And that change will come back to me. But I would have to tell which address that change comes back to. So this is where this output is being created. So the first value of the output is the receiver who gets the amount, and the sender address, which is myself, gets the change. So change is basically the balance minus whatever you are transacting plus the fee. So that change should come back to the sender's address. So this constitutes the input and the output. Then the next value that is required is just the flow data, which can be anything. It could be a text information, which should be a maximum of 1040 characters. Then you basically specify what is the lock time. So the default value of a lock time is 0, which means that for how much time do you want this transaction to be locked if in case. So we just specify it to 0, which is the default value. Replaceable equal to false means that if a higher uh, transaction fee transaction happens in its place, will it be replaced? Do I want this to be replaced with a higher transaction fee transaction? So I do not want that. So I put it as a false. After that, what we do is this object, which is a C# object, this is converted into a JSON value, which is a JavaScript object notation, which is an object that the blockchain would understand. And then I call my create raw transaction API with this particular JSON, and that gives me a value which is in a hex format. So as soon as the create raw transaction API is called, it gives us the hex value, which is the alphanumeric string of values for the entire JSON, and that comes as a hex value. Once that comes up, then what we do is we need to sign that, which is where the transaction signing happens. Now, how do we sign that? We sign that using the sender's private key. We create a signed transaction request object, which contains the inputs that we got, which contains the private key of the sender, which contains the hex that we got from the create raw transaction, and it basically checks which hash type you are using. So there are different hash types that are available in different blockchains. In here, the default value that we are using is all, which means whatever type of hash types can be used, we would be using every. So now we create another JSON, which is a signing request JSON. And then that is sent to another command or API, which signs this using the private key that we have mentioned. As soon as we sign it and it's a success, what we get is another hex value, which is the signed hex, and it is also an alphanumeric value, which is in a hex value. Final object that we create is the send raw transaction, which is basically the one that is transmitted to the blockchain network. Till now, nothing was sent. It was all done by the blockchain node itself. It was creating the transaction, getting the hex, signing the transaction, getting the hex. Now, what we are doing is we are creating the raw transaction request with just the signed hex that we got and creating it in the form of a JSON. And as soon as we do that, if the transaction has enough, if the transaction is valid, it will just be broadcast to the blockchain network. And what we will get in response would be a transaction ID, which is a alphanumeric value, which is unique to the transaction that I make. So any number of transactions that you make on blockchain, every time you will get a unique transaction key. Now, once this transaction is sent to the blockchain, it doesn't mean that it has gone to the blockchain and is part of the blockchain now. Now, this is where as soon as you do this transaction, you get the transaction ID. If you take this transaction ID and go to a Flow Explorer or any blockchain explorer which your blockchain has, you will see that it will show that the transaction is still unconfirmed. And after that, the mining operation starts. The miners start to validate whether the inputs that you have used in unspent addresses, whether they were valid or not, whether you are trying to spend something which you have already spent. So these are all the validations that they do. And once everything is done, then your transaction status changes from an unconfirmed transaction to a confirmed transaction. And that's where this transaction is part of the blockchain. So entire function that I just showed you, this basically creates the transaction, signs the transactions, and broadcasts it to the blockchain and gets the transaction ID in case of a success. So this is pretty much the base of all the transactions that we do.
Oh, thank you, Abhijit. It was very, very nice. And thank you for taking through the code and helping it understand. It's really
Thanks a lot, Amish. No worries.
So maybe you just want to also log in quickly to the Flow Explorer and maybe show one of the default transactions. And
Sure. I'm not sure if I shared my desktop. Let me just quickly open up the Flow site.
So meanwhile, just want to add on to that information. So there is a wallet, a crypto wallet, And so the crypto wallet works on the functions of cryptography. Public key and private key concepts are a part of cryptography. And what Abhijit was showing is a layer of development kit which is built on top of wallet. So all the transactions are, are sent through the API calls that he was talking through, as leverages crypto wallet for that process. Yeah.
Yep. So now you see that this is the blockchain explorer for Flow blockchain. This is something which is hosted by our friends in Ranchi Mall, and they are hosting these Flow site explorers both for the mainnet and the testnet. So if I currently it just waits for all the transactions that are coming into the network. So right now, while we are talking, if there is a new transaction that happens in the network, it automatically starts showing up. But if you look at the top section of this, it basically tells you the latest blocks that have been mined. So it says that these are the block numbers that you see. So if I just put my mouse over any of these, I can see that this is the block number 5518087 with a block hash of this. And the number of transactions that I can see is that this particular block only had one transaction. And it was for a mining operation that was done, which means that someone mined these coins somewhere and they got these 1.56 flow as part of a mining reward. So in here, you can see that this transaction has about 2 confirmations. It means that it has been mined and is part of the blockchain. But if I do some transaction and that transaction is still something which is in progress. So let me just do a quick testnet transaction for you.
You can go to see all blocks, Abhijit, and maybe look at in the old blocks. I'm pretty sure there will be some transactions.
Yeah, absolutely. So what I just wanted to show was something which is uh, basically in undermining and still not transacted. And I
Okay.
just wanted to show something over there. So just give me one sec, please.
Yeah. Yeah, because I believe last time Sugato asked for confirmed and unconfirmed transactions. So
Correct.
Sugato, did you get your answer?
Yes, sir. Yes, sir. I was expecting that. Yes.
To pay for the course to get that answer, is it?
Not really, but yeah.
So I've just started my Flowcore wallet. It should just take a few seconds to open that up.
Sure.
And as soon as it does, I'll just do a quick transaction to my own address only, just to show how a transaction would work. And as soon as we do the transaction, what we would be expecting is that transaction should just come up here. And within a minute or a few, that should get mined. So until that gets mined, we should see the transaction appear here. And if we look at that transaction in the blockchain explorer, it should tell us that it's unconfirmed. And as soon as it gets mined, we will see that it gets the confirmation status. Okay, so this just opened up. That's not very far behind. I'm just 2 hours behind. So let me do a quick transaction in here. Like I want to send to one of my own addresses, which I use for mining. And I'll send about one flow to this, and I'll say test transfer in session. And this is the flow data that we talked about. And what I will do is I'll just click on send and I'll do a quick transaction in here. And it should just come up in my transaction over here. And as well as if you can see on the blockchain explorer, you see that this is the latest transaction. So if I open this in a new tab, you will see that it is still unconfirmed. And in the text, you see that this is the flow data that I sent, which is text transfer in session. This is the address that I used for sending. And this is the address that I used for receiving. The other address that you are seeing, this is the change address, which automatically got calculated by the blockchain wallet itself. So the code where I was showing you the inputs and outputs. So on the left, what you are seeing is the inputs. On the right, what you're seeing is the outputs. And 14.998 flow were transacted, but I just wanted to send one flow. So the one flow was transferred to the recipient, and the rest 13.998 was sent to another address, which is the change address for my wallet. And this was the transaction flow data that happened. And if you see at the bottom, this is the transaction fee that got incurred. And still it says that it is under mining, so it is still not confirmed. So we should be able to see that getting confirmed once we it gets mined. So it should happen in a few minutes maybe. And as soon as that happens, we should have that ready. Just in case if you want a transaction to be mined quickly and if you do not want to wait, you can always run your own miners and mine the transactions if you want the process to happen fast, which in testnet I usually do. When I do not have the patience to wait for the miners to do the job, I mine my own transactions. So that is what you can do as well. But yeah, as soon as that comes in, you pretty much can see. What I would do is I would just like to paste this transaction ID on chat for people to have a look at. And this is the URL that you have. And this is the transaction that we did. What you can do is you can, after the session as well, you can just go to this and see what the transaction was done and just basically look at the transaction, what we talked about, and basically get a hang of it. So right now I can see that the transaction just got mined. So if I come back and get that transaction ID again and look at that transaction in here, now I will see that it has already transact confirmed and we have 5 confirmations and we have got it into a block. So the block which it got included in is this one, which is the block hash. And if I click on this, so this is the block number that we got. So this is where our transaction was pushed in. So you can see all these into this flow side explorer. So yeah.
Cool. Oh, thank you, Abhijit. Thank you for the very
Nice.
detailed session today. Thank you.
Nice. Thanks. Now.
Yeah.
Thanks, Abhijit. Great session. And next week, if you can just introduce the topic briefly.
Sure. So in the next session, we will be continuing with cryptography, but I would just like to speak more about the different cryptographic techniques. So there are 2 ways. One is called as a symmetric cryptography and the symmetric key, and the other one is asymmetric, which blockchain uses. But just to get an understanding of those 2 concepts, we would just like to talk more about those 2 technologies or those 2 methodologies basically.
Amazing.
All right.
Thanks a lot. Thanks.
I hope, Griti, there are no more questions or we are good.
Yes, there are no questions as of now, so I think we're good to go.
Cool. Thank you, everyone. Thanks
Thank
for
you, guys.
Everyone. All right. Bye.
Thank you.